Welcome to this session on monitoring distributed systems at Sumo scale. I'm Gaurav Jain, a senior software engineer at Sumo Logic, and I have been working with Sumo for the last three and a half years. And in my time here, I have majorly worked on improving the reliability and scalability of the log ingest pipeline. And I've also worked on key projects regarding reliability and performance of the log searches. Most recently, I've been involved in revisiting our monitoring strategy around distributed systems, and those experiences are what I'm going to share today here. So I know you have seen these kind of slides a lot of times in the last couple of days. Yes, we are growing very fast, but I will bore you just one more time because the content that I'm going to present here is irrelevant if you are not operating at a reasonable scale. So just some quick numbers here. We are ingesting like 160 terabytes of data every day. We are running about 35 million queries every day, just like Ramin pointed out yesterday. And it's at this scale that you start facing certain kind of special challenges, and that's what I'm going to talk about today. So at the end of this session, I hope that I will have conveyed how and why do you really need to adjust your monitoring strategy as you scale. How you can actually evolve into what I refer to as a customer-centric approach to monitoring. And third, how can you go about understanding the risks involved when you switch to such a customer-centric approach to monitoring. Now, one of the challenges that we have faced as we have scaled so fast, like ingesting almost 160 terabytes of data every single day and accompanied by the same increase in the amount of queries that are running on the platform, a major challenge that we have faced is the increase in the number of alerts that were coming to the on-call rotation. So at one point, we were actually facing 30 alerts every single day. And it's like almost out of 24 hours in a single day, 16 hours, we were getting interrupted by pager duty. So this has multiple consequences. First of all, obviously, the on-calls are not happy. They are irritated. They are frustrated by all this noise. And then the days are not productive. And more importantly, there is on-call exhaustion because of this. And people actually start ignoring the real alerts amidst all this noise. And when they actually start ignoring the alerts, it actually ends up compromising the reliability of the system, because when there is an actual issue going on, there is nobody to take care of it. So those were the real problems that we were facing. And I can't emphasize it enough here, but I strongly relate to that software is for the people and not the other way around. So you should, such a huge number of alerts is just not sustainable, and you should do everything in your power to fix that. And this was not just a one-off problem. This problem was persisting continuously. So 30 alerts every single day, and that problem was like coming at us for multiple months. So we realized that this is a good opportunity for us to actually revisit our monitoring strategy and see if there is something fundamental that we can change about how we monitor our systems so that we can have a much more sane on-call policy. Now, whatever I'm going to say here is not just some theoretical thing. It is something that we have actually applied to our production systems and applied them with quite a reasonable success. So when we started to revisit our monitoring strategy, we were very clear about the goal that we had in our mind. So from 30 alerts per day, we were very clear that we had to at least reduce the alert volume to around like 5 alerts max per day. That is, of course, the initial goal. We actually planned to go further than this, but this was the goal that we started with in mind. So maximum 5 alerts per day, and because only then you can have a sustainable on-call policy. But the Uber goal of 5 alerts per day did not come free. It came with its own baggage, and it came with its own sets of terms and conditions. So those terms and conditions were these. First of all, any decent monitoring strategy that we were planning to switch to, it was necessary that it had no false positives. So whenever you have an alert, it had to be an actual urgent issue going on in the production system right there and then. Second requirement was no false negatives. So it's just a mirror image of the first requirement, which says that whenever there is a production incident going on, you must be getting alerted. And the third is alerting with enough headroom to react. So you might have a very you might have a very perfect system that has no false positives, that has no false negatives. But if it is alerting you like 1 hour after the incident has happened, it's of no use. The damage has already been done. So you need a monitoring strategy that tells you about real issues in your system well ahead of time so that people can come in and react. So with these conditions in mind, we went back to the drawing board and analyzed all our alerts. And one thing, and there were actually two buckets that stood out for us. One was, the first bucket was for the alerts that actually used to make sense, like maybe a couple of years back or 3 years back, those alerts did not make sense anymore. So for example, we had alerts in our system such as a node not being SSHable. So if a node can't be SSHed into, we were getting actually a high priority alert for that. Now to be fair, this alert actually made sense maybe 3 years back when a single node going down in the backend could actually impact our customers. But over the course of time, we have actually built a lot of fault tolerance into our system, and we today have all sorts of mechanisms like fallback clusters, we have hysteric circuit breakers, and we have straggler detection and remediation. So those kind of things have been built into the system, but our monitoring strategy has sort of not kept up pace with that. So in a sense, our monitoring strategy was lagging behind the state of the art of our backend systems. And that's why this was one bucket of noise that we had in our alerts. The other bucket that we had, which was contributing to the noise, was alerting on a lot of low-level metrics which might or might not impact the customers. So for example, we had a lot of low-level metrics like CPU utilization, and then we had something like amount of time spent by a node in garbage collection, those kind of very low-level system metrics which were actually resulting in high priority alerts. Now, in a multi-layered microservice architecture, it is very hard to tell whether something going wrong on a particular node can actually manifest itself as a customer impact. It's just damn hard to say that, to just pinpoint at a particular node and say that if a node goes down, then some customer query failure would happen, or a customer query would actually suffer performance. So with these we had these two conditions in mind, and then we started to look at, like, given this is the source of noise, how can we actually go about to find a monitoring strategy that has a very high signal to noise ratio. So if you have been following the discussions in the wider monitoring community, you will come across things like the golden signals. This is from the SRE book by Google. They talk about these 4 golden signals: the saturation, traffic, latency, and errors. Similarly, we have use strategy by Brendan Gregg of Netflix fame. He talks about utilization, saturation, errors. Those are all similar kind of signals. But we realize that if we are going to adjust our monitoring strategy according to these signals, we are still not going to get rid of the false positives. So we realized that we had to move up higher up the stack if we really wanted to get rid of the false positives. So that brings me to what we refer to as the customer-centric approach to monitoring. And this customer-centric approach to monitoring can be summarized by 3 rules. The first rule says that we should only alert on customer-facing business metrics, and only those issues that actually require immediate attention. So to take an example of this, right now, after making this shift to the customer-centric approach, we only alert on things like customer query failures, customer query slowness, and ingest lag. These are like very visible things to the customer, and we know that if something is going wrong with these metrics, our customers are definitely getting impacted. And those are the things that we should really care about and alert on. Now, if you note this rule number 1 very closely, you will find that it ties back to all 3 conditions that I listed earlier: no false positives, no false negatives, and alerting with enough headroom to react. So if you are alerting only on business metrics, you are bound to have no false positives, because you are alerting only on the business metrics, and that's why whenever you get an alert, it's an actual production incident that matters to the customer. So no false positives. Then if you have done your homework decently, then you will have a decent coverage of business metric alerts, and thereby you will never have any false negatives, because just because you have a decent set of business metrics covering all the important issues in your system. And the third one is alerting with enough headroom to react. The way this rule ties to that condition is by the thresholds. And I admit that this is the most trickiest part of this rule, getting the thresholds right, because if you don't get if the threshold is set too low, there will be a lot of noise, and if the threshold is set too high, you will be you will get alerted very late. So it's very important to involve people with all the operational expertise and the SMEs in this process to decide the right thresholds, because it's because if you don't get this right, then you won't be alerting your people with enough headroom to react. So, but even that being said, be prepared that you might not get your thresholds right the very first time, and it will likely evolve over time. So this is about the what of the thing on which you should set your alerts on. The second the second rule is exactly how to implement these business metric alerts. So, for example, you have a business metric which says alert on customer query failures. Now, there are multiple ways of going about it. Either you can go and look at all the causes that can actually result in customer query failures. For example, there might be an under-provisioned cache which can result in query failures. There might be some network issue going on in your system which might result in customer query failures. But if you actually start going down that route, that figuring out all the causes that might result in a business metric getting impacted, it's a never-ending trail. You will never have a complete coverage, and you will always leave some holes there. So it's just simple to directly measure your business metrics and set your alerting on them. So if you are going to alert on customer query failures, just measure your customer query failures and alert on them. Forget about all the root causes that might actually impact this business metric. So that's about and if you again go back to the 3 conditions that I listed down earlier, this goes back and ties to having no false negatives. So if you have an alert that directly measures business metrics, you are bound to have, and you will never have any false negatives, because it will provide you a complete coverage. The rule number 3 is the rule of exceptions, and it should be applied only in very rare scenarios. So we all know that we have certain hard dependencies in our distributed systems. For example, in our Sumo backend, we have Zookeeper as one of these dependencies. So we use Zookeeper for very critical things like service discovery, for storing the configuration metadata, for leader election, for taking distributed logs. So Zookeeper cluster that it's like a glue for our entire microservice architecture. And if something is going to go wrong with the Zookeeper cluster, we definitely know that a lot of our microservices are going to get impacted, and yeah, we know that the ship is going down. So these are the kind of exceptional cases, and also we know that whenever there's something wrong with the Zookeeper cluster, it's not very straightforward. So we need all the headroom that we can to remediate such issues. So it's only in such exceptional cases that you can think of actually alerting on these causes that can actually impact your business metrics. So hard dependencies like Zookeeper, or maybe in your system, it might be some other sort of hard dependencies. And if you are 100% sure that when anything goes wrong with that particular dependency, it is definitely going to impact your business metrics, you might want to put your alerting on those causes as well. So these are the 3 rules that actually summarize the customer-centric approach: alerting on the business metrics, directly measuring the business metrics for your alerting, and the number 3rd was the exceptions, which says that you can alert on causes that are 100% sure, 100% guaranteed to impact your business metrics. Now there are definitely some risks associated with transitioning to such a customer-centric approach. And one of the very first things that will pop up is how do you go about debugging production incidents? Because now you are alerting on a very high level, because now we are alerting on things like customer query failures, customer query performance, ingest lag. So these are things that can be very, very far removed away from the actual cause that is causing this impact on the business metrics. So for these things, so in a sense, the MTTI for production incidents might go up. So the way we have actually mitigated this risk is by investing in Playbook style dashboards. So what this dashboards shows is, it shows how, this is a dashboard for one of our business metrics, that is ingest lag. So ingest lag is like the difference in the time that a customer sends some data to Sumo and the time it becomes visible in Sumo. So that's the time difference. So that's what we refer to as ingest lag. Now this dashboard has been made in the spirit of a playbook. So this dashboard actually lists down all the steps, starting from what is the lag actually, what are the customers that are getting impacted, down to the level of which node is actually resulting in that particular ingest lag. So anyone who has even a tiny bit of operational expertise, he can just go through this playbook, and 90% of the time he can actually remediate a business metric, an alert that is impacting a business metric. So yeah, if you are transitioning to such an approach in which you are only alerting on a high level business metric, please do yourself a favor and invest in such playbook style dashboards that can actually take you through from the high level business metric to the actual cause that is causing them. I know this is not very straightforward always, but if you don't do this, you are definitely going to regret switching to the customer facing business metrics. Another thing that has actually helped us debug these production incidents very fast, while having alerting on the basis of these high level business metrics, is an aggregated view of all the health checks that we have in our system. So this is just a web page which actually puts all the health trackers, all the health checks that exist in our entire microservices on a single web page. And this has some very useful filters. For example, you can have a filter on the basis of which are the health trackers that are unhealthy. You can filter them by the node. You can directly jump to the microservice. And so whenever there is a business metric alert firing on, you just go to this web page, you drill down, you type in the service that is actually relevant there, and you will get all the health checks that are actually read at that particular moment. So if for example, a particular node has a high CPU, it will show up here. If a particular node is doing high GC, it will show up here. So with the help of this thing, and also at the right, you have the playbook links right there. So whenever you find a red health tracker, you can directly just jump to the playbook and actually follow all the steps to remediate that. So these two things, playbook style dashboards and this aggregate view of all the health checks that we have in our system, has actually helped us to make sure that even though we have our alerting on such high level metrics, the MTTI doesn't increase. We have been still able to keep the MTTI under control and debug our production incidents faster, at the same time reducing all the false positives and problems like that. Now, the second risk, and in fact, a very common question that people will ask you when you are making this switch to customer-centric approach, alerting on such high-level business metrics is, what about the leading indicators versus the lagging indicators? Because when you're alerting on a lot of low-level metrics, you are definitely getting a lot of head start, but that doesn't come free. You are actually also, with that head start that you are getting, you are also getting a lot of false positives. For example, if you are alerting on CPU utilization, for example, so yes, it might give you a head start 1 out of 10 times, but 9 out of 10 times, possibly it is not even impacting the customer. So it's a trade-off between getting an early head start versus getting a false positive. Now, to remediate this kind of risk, what you can do actually is put in auto remediation as much as you can on these low-level metrics. So for example, if you have a low-level metric such as CPU utilization, put an auto remediation in there that whenever the CPU reaches a threshold of 70%, 80%, just restart that node. That kind of auto remediation is really, really helpful because it's like killing 2 birds with a single stone. So it's like giving you the advantage of the leading indicator, because as soon as that low-level metric is breaching a threshold, you have your auto remediation kicking in and remediating the whole problem. And at the same time, and all these auto remediations will actually work most of the time, and But in those cases when they don't work, you won't be actually looking at them until it's actually impacting a customer-facing business metric. So it's like reducing the false positives as well, while also giving you the advantage of leading indicators. So I just can't emphasize this again enough. If you are actually planning to switch to a customer-centric approach, don't just erase away all the low-level metrics that and the alerting that you have on them. Instead of getting rid of them, put your auto remediation things into action and base them on all those low-level metrics alerts. That will give you a very good safety net and ensure that you still respond in time to any real production incidents. So the outcome of this all. So we had when we started this thing about 3 months back, we owned like 12 microservices and we had like 250 unique alerts firing in the last 6 months. And after this exercise, first of all, we decreased the number of unique alerts that could actually fire to around 35. We identified like 3 business metrics per microservice. So in total, around 35 business metrics, down from around 250 high priority alerts that were firing earlier. And the end result of it all was that right from firing 30 alerts every single day, we came down to around 7 alerts per day. So that was like a huge win for us. And in terms of productivity, we recovered like instead of interrupting people like 16 hours of the day, we were interrupting them only now 5-6 hours of the day. That was like we were recovering like 23 man days every month. That's like one free developer every month, every week. Other results were like happier on calls. We had now more productive days, and the third point is like now all these alerts that we were getting were now really actionable and they were really urgent alerts. No more thinking about like, okay, there are so many alerts going on, this might be just useless and it's okay if I don't respond to it. So it brought back the sanity back in the on-call. It brought back the urgency in the on-call policy, and people were now actually thinking that, yeah, if your phone is buzzing off, it's a real issue going on in production. And lastly, it actually helped us with a philosophy of how to decide when to put a high priority alert and how we can make do with something that is low priority. Earlier, like when you're just starting out, you're pretty liberal with how you put in alerts in your system. Like somebody might put in an alert for even an illegal state exception, things like that. But now we have a set of rules, a set of guidelines that can actually help you decide that whether this thing actually warrants a high priority alert or not. There is more though. It's not actually just enough to transition to such a customer-centric approach, because it's not a one-time thing. Because if you do it once and then just walk away, things might get worse again. So what we have tried to do in Sumo is like try to institutionalize this customer-centric mindset. We have tried to actually make this term business metric a part of the mainstream, like the part of the lingua franca, that the way we talk to each other. And one very small way that we have tried to do this is like we have prefixed all our high priority alerts with the name business metric. So all our high priority alerts now start with business metric customer query failures, business metric ingest lag. This is a small thing, but what it has helped us achieve is that now people talk in those terms, and now it has helped us. It has helped the team adopt such a mindset, and now everyone in the team is an advocate of this kind of philosophy. So now if anyone comes up with an alert that is not actually impacting a customer business metric, people are actually bound to question that thing, that how is this alert a high priority alert even though it is not a customer business metric. So just by these small things, we have been able to institutionalize this mindset, and hopefully the things will stay that way. So to summarize, when you're growing, when you're scaling, you might need to adjust your monitoring strategy. Things that used to work yesterday do not necessarily work today. As a solution, as a possible solution, you can actually try this customer-centric approach to monitoring and evolve into this customer-centric approach. which is summarized by 3 rules. The first one being alert only on business metrics. Second rule being alerting by directly measuring the business metrics, and the third rule being alerting on causes that are bound to impact your business metrics. And there are 2 major risks that I identified with such an approach. The first one was debugging production incidents. That can be tackled by investing in Playbook style dashboards and having some sort of an aggregate view of all the health checks in your system. The second risk was, of course, about lagging indicators and leading indicators. And that can be taken care of if you have auto remediation in place. So yeah, that's it from my side. I hope you enjoyed it. Thanks.
Go one more. All right, thanks, Gaurav. If anybody has a question, please raise your hand.
You talked about Playbook-style dashboards and putting it all together on a website. Can you please help us with letting us know what website or tooling did you use for that?
It's like a homegrown, it's just a simple web page. So we have these health checks in our system that are instrumented via code. So whenever we put health checks in our system, such as let's say there is no query arriving on a particular node, then trigger a health check. So that health check is actually triggered by storing the information about that particular health check in Zookeeper. And then we have a web page server which actually pulls this information from Zookeeper and dumps it over here. So like, again, health checks is also one of the things which we use Zookeeper for. And it's like you can publish all this information in one central place and then have a web server pull it from there. That's how we do it.
Okay, thank you.
Thank you.
You provided the metrics of going from 30 incidents a day to 7. Did you also track if there was any increase in time to respond or in customer issues noticed?
Yeah. So every time we have an outage, we have a postmortem. And one of the things that we track in our postmortem is time to identification and time to remediate and time to recovery. And for each of those 3 things, time to identification, remediation, and recovery, we have to actually break down the reasons, as in what led to those times. And at least in last 3 months, we have not seen a single postmortem or an outage where the reason for all that time to identify was one of these things, like we did not have an alerting on a low-level metric. Because usually we have been able to track down the real cause in just a few minutes, and that's in very small proportion to the entire outage duration. So yeah.
Yeah, you mentioned auto remediation. What kind of tool sets do you use, and how do you track those from, if you have anything where it keeps running or it's an actual problem?
So for auto remediation, we have again a homegrown tool. We call it SAR. SAR is just Sumo auto remediation, and it's very similar to, I think it was inspired by one of the blog posts by Facebook. They also have something similar which does this self-healing. And the way that SAR tool works is that whenever there is an alert that is triggering, it takes the information from that alert about like which is the node that is triggering this alert and what are the thresholds that are breaching. So it has all this contextual information about it, and then we can actually encode what are the things that a real on-call person would do in when he's faced with such a situation. So if it's a node doing high garbage collection, we just restart that node. And this tool is actually integrated with our deploying machinery. So this tool has all the access to our production systems, and it can do stuff like restarting them or increasing their heap size, all sorts of stuff. But it's a homegrown solution. I think.
You have a follow-up?
Do you actually track those over time too to see if you have something that's just continually rebooting
Yeah, so
or
that's
cycling?
the very next point that we want to do. Like actually we are not very far on the auto remediation front so far. So we are still doing that. As I say this, as I'm presenting this, someone is actually doing these auto remediations in the Noida office. And yeah, that's the plan for us, that once we have a lot of these auto remediations in place, we will try to put some sort of low priority alerting on how many auto remediations we are doing, because we just don't want to live with just the auto remediations. We actually want to fix the real issues as well.
Okay.
So,
Thank you.
yeah.
Those are good questions. Any others?
Is all of your alerting based on Sumo logic, or do you have other third-party tools that are doing some of that alerting for you as well?
A majority, so the answer to that is partly yes and partly no. One of the challenges that we have personally faced with Sumo logic alerting is that you have to actually maintain. So if you are alerting via scheduled searches, for example, you have to actually go and set up those scheduled searches in each and every single deployment. Now we have like 5-6 multiple deployments right now, and it's actually a pain to just reconfigure those alerts in each of those 5-6 deployments. However, that being said, that problem will be probably solved very soon, given the announcement today also with the Swagger APIs. So once we are actually able to encode those alerts via code, that should not be a problem, and we should be able to completely shift over to scheduled searches alerts. But that's one of the reasons, because it's just such an overhead to configure all the alerts in all the different deployments, that we have another homegrown tool that we, for the time being, use for alerting.
We're not that dissimilar to you guys. So, any other questions?
Hi. So we're kind of halfway to what you explained, and let's say half a piece of the company they buy these ideas, but we have the kind of traditional alert department which has these low-level alerts. How can we convince them?
How can we convince them? To be honest, at some level, even in Sumo logic, so this part, whatever I described here, that was done within the search team that is like owns the log search part of Sumo logic. And to be honest, not everyone agrees with it even right now. But at some level, you have to take ownership for it, that I am responsible for running this service, and either I run this service this way, or I have to live with these 30 alerts per day. Either you provide me a better solution for this problem, because I am not going to live with these 30 alerts per day. Like, we were pretty confident in our approach. That's why we did our homework before rolling this change out. We invested in debugging Playbook style dashboards, and we invested in creating this culture of looking at all the aggregated health checks. So that, because we were pretty sure that if something goes wrong, there is an outage, and one of the reasons that is identified is that, oh, we did not alert on a CPU utilization threshold. People are going to come back at us like really hard. So we made sure that that's why it was a very slow process. It took us like 3-4 months to actually roll this out, and a majority of that time was doing our homework to make sure that, for example, to identify all the causes that actually impact your business metrics 100% of the time. We actually went down the list of all those 250 alerts, every single one of them. We sat down with the SMEs to figure out if we are really not missing out anything. So this is like just a gist of what we did, but it was a very laborious process, and you have to be very careful before you roll this out, just to make sure that nothing goes wrong when it's out there in production. Yeah. And if no, there will always be people who don't agree. So what? Like, you have to own that. There's a saying like, if two people agree with each other, then one of them is redundant, right? So.
Show the value. I think that, that's what the team did. If you can show the value, you can show that, you still provide the same results. Metrics, logs. Right. Any other questions? All right. Thank you, Gaurav.
Thank you.
Can you click on next?
This
Yeah.
thing.
Thank you.